Assalamualaikum and hello everyone. My name is NURUL SYAZWA TASNIM BINTI SAIPUL BAHRI from AS 2294A, and today I'm going to present about Practical Module 3. The objective are to learn the technique to buffer and overlay from the spatial data, to understand the function of spatial analysis, to understand how to merge two or more feature classes, vector 5 or raster 5 into one single feature class or raster dataset, to understand fundamental GIS using ArcGIS, to familiarize component in ArcGIS, and lastly to recognize geospatial data. Next is methodology. First, create a new map. Drag derive sheet 5 to the table of content, and then left click on the red out toolbar to activate the tools menu, or you just can right click here and our toolbar will appear. Click on the analysis tool and then proximity. Click on buffer. On the input, click derive. On the output, write derive buffer 300. For the linear unit, write 300, make sure it's in meter, site type is full, dissolve type is all. OK. When the buffering process is finished, it should display the data layer. Derive buffer 300 appear, zoom to layer, next we do the derive buffer 309, click on proximity and then buffer, we choose derive, and then for the output we write derive buffer 309. Save. Linear 300 in meter, site type is full, and then dissolve is 9. Click OK. The derive buffer 309 is appear. First, drag the district lantern to the layer. Open the toolbar and then go to the overlay. Click erase. On the input feature, we choose derive buffer 300, and on erase feature, we click on derive. On the output, we name as derive erase. OK. Once you have erased the leaks from the leaks buffer layer, the final step is to overlay the two buffer layer. Go to the art toolbar, analysis tool, and then overlay union. On the input, we choose district lantern and derive buffer 300. On the output, we name as derive district union. Save. OK. Alright, as we can see here, we must examine the union layer by opening the attribute table for this layer. Select the polygon that meets both the within the roots buffer and the within the legs buffer criteria. On the derive union, open the attribute table, highlight the name, and on district lantern, open the attribute table and highlight the name. After that, to determine the site experience highest water reservoir or retention, overlay the derived shapefile district Kelantan by double-click on Intersect tool. Go to the Arc toolbox and then Analysis tool, Overlay, and then Intersect. Double-click on the input feature, Derive, and District. On the output, we save as Derived District Intersect. Save. Okay. After that, go to the file, save as Module 3. To the table of content, go to the Arc toolbox, Conversion tool, Excel to table. For the input Excel file, click on Datagram 1 July 2015, and then OK. Right-click at the table datagram on Table of Content to display the data into point. Display XY data. For the X field, go to the E, Y field, go to the N, and Z field, go to the none. OK. And then go to the data, export data. Change name to PM10. OK. On the main menu, click Customize, Extension, check the Geostatistical Analyst and Spatial Analyst. Click Close. Then to add the Geostatistical Analyst toolbar, on the main menu, click Customize, Toolbar, Geostatistical Analyst is on mode. It appears right here. Create an interpolation a surface of PM10 using a default Geostatistical Analyst setting. Click Geostatistical Analyst and then click on Geostatistical Wizard. The Geostatistical Wizard will appear and then click on Inverse Distance Weighting. Source dataset is on PM10, data field on PM10. Next. And then right-click on the layer, click Properties, and then click on Data Frame. Extend is on the Automatic, and Extend used by full extend command. Click Others, specify Extend, Outline of Feature, change to Daerah, and click Option. Click on Clip to Shape, specify Shape outline of feature and change to daerah. Click OK and OK. After that, right-click on Inverse Distance Weighting, click on Properties, Extent, and change to the rectangular extent of the daerah. OK. Change the position for the daerah. Change the hollow. Next is right-click on PM10, Properties, click on the label, tick on label, and make sure it is a station. OK. And the label will occur. Next, we move to the kriging. Click on Geostatical Analyst and Geostatical Wizard, and Geostatical Wizard box will appear. Click on kriging. Change data field to the PM10. Next. And kriging type is ordinary. Next, 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 finish. And it will appear like this. Click on kriging, Properties, Extent, change to the rectangular extent of the daerah, and OK. Discuss how do the results differ between dissolve more than none and dissolve more than none in buffering, and when would this be important? After inspecting, remove the not dissolved layer. Dissolve more than all. Individual data buffer are integrated into single feature in this product, and regardless of overlap, a separate buffer is kept for each feature, and this is the standard. And for the dissolve more than none, remove any overlap by combining all of the buffer into a single feature, and overlap may occur in order to eliminate each feature. The none option for the dissolve type parameter add above this property to the output feature class that display the buffer distance for each feature. And using the all option for the dissolve type parameter, all buffer polygon will be dissolved into a single multi-part polygon feature. And for the dissolve more than all is a simple feature graphic output, and dissolve more than none for detailed feature graphic output. Next is screen capture each overlay analysis done and explain the overlay feature. First is buffer. It is a reclassification based on distance, with the categorization being within or without a certain closeness, and it entails calculating distance in all directions from an object. And second is erase, the feature that will be utilized to remove coincident input feature, and the selected area will be removed and a new shape class will be displayed in its place. For example, its river have been removed from the map. Third are union. The borders and properties of all input features are preserved while the input data layers are combined into a single composite layer, and whenever the feature overlap, the separate features are created for them. For example, the combining state area with the river shape. And lastly is intersect. Differentiation of intersected feature using a method, and this technique will produce a data layer with all intersected polygon shape of all data. For example, is finding the area's river and drain line flow intersection. How is the XY terrain defined in the intersect dialog, and how many records does final shapefile have? As we can see here, the smallest distance between the coordinate before they are regarded equal is referred to as the XY tolerant. The XY tolerant is left blank in this intersect dialog. It appears to be set to default setting. And next is, as we can see how many records this final shapefile have. At the end of the district intersect, there were 343 records for the final record. Highlight all spatial analysis performed in this practical and relate the function of each analysis with real application in environmental context. First is buffering. Buffering is the process of calculating and measuring distance outwards from an object duration, and it measures distance in all directions outward from an object. It works with all three types of vector data, which are point, line, and areas. And the buffer that results is a polygon file. And for the example, due to the significant increase in traffic, town planner wish to enlarge the main road and add a second lane. Hence, a buffer zone is constructed around the road to identify houses that lie inside the buffer zone. And second is overlay. Overlay is multiple data layer that examine in one output with this type of analysis, and it's frequently combined with other sorts of analysis such as buffer or slope tools. For example, overlay analysis can be used to identify cotton soil compatibility. You have tried several types of interpolation method, screen capture the output and explain based on observation the differences between all the methods. There are two: inverse distance weighting and kriging. Inverse distance weighting or IDW is deterministic method, and it is an interpolation approach that demonstrates the relationship between the distance and weight in regard to the spatial data. And inverse distance weighting is mathematical data, and it's based on the nearby measured values and unknown value was anticipated, and the weight is given to the measure point that is closest to the projected position. And also, the bullseyes are produced by a heavy weight at particular points. And for the kriging, is a geostatistical method, and it is an interpolation method for the spatial data that display the relationship between the distance, duration, and statistical data. And mathematical and statistical data is for the kriging, and based on the average between the location, an unknown value was anticipated, and with no exact point, the collected average form a polygon shape of the affected areas. Summarize the use of geostatistical analysis used in this practical in environmental study. Inverse distance weighting, or the IDW, is a process that uses weight and distance correlation to forecast an unknown location. Meanwhile, for the kriging is a method for predicting an unknown location based on distance, duration, and statistical data. And IDW use deterministic method, and meanwhile for the kriging it uses geostatistical method. And for the IDW, it's suitable for the input dataset with a wide distribution. Meanwhile, for the kriging, when a large input dataset with a poorly dispersed distribution was obtained, this method was widely used. And next, we move back to the inverse distance weighting. IDW employs the measured values surrounding the prediction location to predict a value for any unmeasured place in this analysis. Meanwhile, for the kriging is a statistical method for calculating the spatial autocorrelation between location at graduated distance using variograms. It is useful in soil science and geology. And lastly, for the example for inverse distance weighting is measurement from meteorological station were used to estimate air quality index. And for the kriging, the example is topsoil analysis of e-waste recycling facilities in Cameroon was determined using this method. These are the references that I refer while doing the practical module 3. That's all from me. Thank you so much.